Hello and welcome to our lesson on graphing linear equations. This is going to be from section 2.6 in our text, and I've got some notes we need to go through before we jump into the examples. So what I have written here is I've got three forms of linear equations. The general form is the first one I have written here, and what you need to remember about general form is that that's going to be equal to 0. So you've got your ax plus by plus c, if there's a constant, equal to 0 represents general form. The standard form has the constant on the other side here. So this would not be equal to 0. It would be equal to the constant. So you'll have your ax plus by equals a number, and that number could be 0. But here you're not going to have another term on the left other than your x and y term. And last we have slope-intercept form. And the thing you need to notice about slope-intercept form, notice we have y by itself. So if you've got y equals some stuff, then that's going to be slope-intercept form, where m is the slope and b is the y-intercept. Now, notice that standard form and slope-intercept form have a graphing technique. General form does not. So if your equation starts off in general form, you're going to want to convert it to standard form or slope-intercept form in order to graph. And it's super easy. If you're in general form, all you need to do is take that constant and move it over to get to standard form, or get the y by itself to get to slope-intercept form. So we're going to look at a few examples. I'm going to cover the intercepts method and the slope-intercept method, and then we're going to look at a couple of special cases, and that'll do it for this lesson. Okay, our first example, we're going to look at number 5. Here we have a linear equation, and if I haven't talked about this yet, you're going to know it's linear if the variables have exponents of 1. That's how you know your equation is linear. The next thing we notice is that this equation is in standard form. So if we scroll back up and look at standard form, you're going to have your ax plus by equals c. And here we can see that that does fit the format for number 5. So since we're in standard form, our graphing technique that we're going to demonstrate is the intercepts method. So here's how the intercepts method works. You're going to start with a table. You're going to let x be 0 one time, and then you're going to let y be 0 one time. So if I let x be 0, the 2x will go away because 0 times anything is 0. And that will leave me just 3y equals 6. I can divide both sides by 3, and we can see that y will be 2. Now, the reason this is called the intercepts method is because what we just found is the y-intercept. Anytime x is 0, you've got the y-intercept. And now we're going to let y be 0. So if I let y be 0, the 3y term will go away, again because 0 times anything is 0. That'll leave me 2x equals 6, and I can divide both sides by 2 and get x is 3. And that ordered pair is the x-intercept. Anytime y is 0, you have the x-intercept. And how many points does it take to make a line? Only 2. And we've got them, so let's plot them. So again, this is the intercepts method because you're finding the x and y intercepts. So 0 and 2, that's the y-intercept. 3 and 0, x-intercept. Plot the points, connect the dots, and you're done. Next, number 19, here we have a function f of x equals negative 5 halves x minus 4. Don't let this part throw you off, okay? If it's a function f of x, just remember that f of x means y. So we can rewrite this function as a linear equation. It's going to say y equals negative 5 halves x minus 4. And since we have y by itself, this is slope-intercept form. So we're going to demonstrate the slope-intercept method of graphing this time. Here we have our slope is negative 5 halves. Remember that slope is rise over run. And so for our slope, we're going to rise negative 5 and run 2. And it's important to point out that this negative can go with the numerator or the denominator, either one. It doesn't matter. And when I go to graph this, I'll show that. The other piece of the puzzle we have here, the negative 4, is the y-intercept. Now remember, the y-intercept is an ordered pair where x is 0 and the negative 4 is the y-coordinate. Plot the b. Remember, that is the y-intercept. So we're going to plot the b, and then we're going to rise and run. So how do I rise a negative? Well, to rise a negative means to go down 1, 2, 3, 4, 5, but then the run is positive, and a positive run goes to the right. So again, plot the b, rise and run, connect the dots, and then you're done. Man, I love that. Plot the b, rise and run, connect the dots, and then you're done. So freaking awesome. Now, remember I said that negative on the slope could go with the top or the bottom, either one. So now let's pretend that we decided to put the negative with the denominator. Now notice my rise is positive. So to rise a positive means to go up 5. So if we do the poem again, we're going to plot the b. 1, 2, 3, 4, 5. We're going to rise 5, but now my run is negative, which means to go to the left. 1, 2. And notice that, well, first of all, notice that my line is a little bit off, but these points will line up. So it doesn't matter if you rise a negative and then go to the right, or rise a positive and then go to the left. Either way, you're going to get the points that make the line. All right, number 9 is different than either of the previous two examples because it's not in standard form, but it's also not in slope-intercept form. So what I'm going to do is I'm going to work this both ways, showing both forms, and then you can choose which one you like better. So the thing I'm going to start with is I actually kind of prefer slope-intercept form. Notice that my y is almost by itself. So I'm going to go ahead and divide everybody by 5, and that'll get me into slope-intercept form. And what I'm going to do is I'm going to switch the order of these two terms so that it is y equals mx plus b. So that's going to be y equals 3/5 x, that's my x term, minus 15 divided by 5 is 3. And now I'm in slope-intercept form. And so now if I go to graph this using my poem, I'm going to plot the b, which is at -3, and then I'm going to rise and run. So from the y-intercept, I'm going to rise 3 and run 5, and that'll get me to a new point. Okay, one more time. Plot the B, rise and run, connect the dots, and then you're done. Love that. Now let's look at number 9, version B. Let's assume that you want to go to standard form instead of slope-intercept form. And so here that would be super easy. All you have to do is bring the 3x over, which will make that negative 3x plus 5y equals negative 15. And I think something important to point out would be that technically standard form needs to have a positive a. So this ax term really should be positive. So what I could do is I could multiply both sides by negative 1, or the easier way to deal with that would be to just change all the signs. I mean, technically, that's what multiplying both sides by negative 1 would do. Legally, I can just go through and change all the signs. As long as you do it to everybody, that keeps it legal. And then I'm going to have 3x minus 5y equals 15. And now I'm in standard form, and I can use the intercepts method to graph. So we're going to make our table. We're going to let x be 0 one time, which will make the x disappear like that. And then if I divide by negative 5, that's going to give me y is negative 3. Next, we're going to let y be 0. And if I let y be 0, that's going to make the y disappear like that. And then if I divide by 3 to get the x by itself, that's going to give me 5. So now that I have the y-intercept and the x-intercept, I can go to the coordinate system. I can plot my two intercepts, 1, 2, 3, y-intercept of negative 3, 1, 2, 3, 4, 5, and connect the dots. Notice that no matter which technique I use, I get the same graph. Man, that is awesome. I don't know, how can you not get excited about that? That I've got two techniques that I can use, and you can choose whichever one you prefer, and you're going to get the same answer. Now we're going to cover the two special cases. For number 29, I want you to notice that we have an x and no y. That's going to always be a vertical line. So x and no y indicates a vertical line. And so this is going to be super easy to graph. All I have to do is go to where x is, and then I just make a vertical line. And just for fun, I'm going to throw in a couple of bonus features here. First, the slope of every vertical line is undefined. And if they ask you for the y-intercept, you're going to say, nope, not going to happen, because this vertical line is going to run parallel to the y-axis, which means that there is none. There is no y-intercept. And number 31, here we have y and no x. So, looking back at 29, if x and no y is vertical, what do you think y and no x is? Yeah, it's horizontal. So, these are the two special cases you're going to need to remember, okay? X and no y is vertical. Y and no x, horizontal. And so to graph that, again, this is going to be super easy. All you need to do is go to where y is. Here it says y is at negative 1. And you make a horizontal line. And again, to throw in a couple of bonus features here, the slope of every horizontal line is 0. Every horizontal line has 0 slope, or you could say no slope. Zero slope is the same as no slope. Okay, now undefined slope is not no slope, because if you look at a vertical line, it's got a whole lot of slope. So much you can't even calculate it. But zero slope and no slope are the same. And for a horizontal line, there will always be a y-intercept. Bam, and that's where y equals whatever it is. Y equals -1. Your y-intercept is going to be that point, 0, -1. And that's going to do it for this lesson. So if you have any questions or comments, feel free to leave those in the comment section below, or you can text me. And thanks for watching.